Hello everyone. A few days ago, I was playing around with making games with things like TypeScript and HTML, and I decided to try out making a platformer game. And platformer games are pretty nice to make because it has a lot of logic and stuff that a lot of games will use. Stuff like collision detection and physics, for instance. So in this video, I'll be showing you guys how to make a platformer game with TypeScript and HTML. And we'll also learn some other tools like Webpack and just the HTML canvas mainly. So to start off, I have this empty directory open. Actually not empty, I have a license and readme, but that's not important. And we will just install some dependencies. So, I'm using Yarn for this video. You might want to make sure you have Yarn installed, but npm will also work if you know how to use that. So I'm just going to yarn add -d, and I'm going to install TypeScript. I'm going to install Webpack, the Webpack CLI, and the Webpack dev server. Now, these are basically all the packages we'll be using. TypeScript just for the language, and then the rest of these are for Webpack, or just bundling the code. So press enter, and that'll probably take a while to run, so I'll see you in a bit. Alright, so the package is finished downloading. So now we can take a look at the package.json. So I'm using NeoVim for this tutorial, but any other text editor will work, such as VS Code and otherwise. So as you can see, I have some dev dependencies here. TypeScript, Webpack, Webpack CLI, and Webpack dev server. I'm just going to add some extra stuff to make this development process easier. So first off, I usually like to include a private true in my package.json. This just tells npm just that this package is private and it should not be distributed. Basically, you don't want anyone else to be like downloading this, not for the sake of just like security, but just because, well, no one will want to download this. And second of all, we want a scripts object, and this will include some like templates that we can use, or like just simple like macros, I guess. I don't know what it's called. So we will have a script called dev, and we will run webpack serve mode equals development. So what this will do is it'll serve Webpack in development mode. Pretty simple. Now, we need some more configuration. So I'm going to open up a new window, and let's take a look at the other options. So, if we cd into our directory, we need a tsconfig.json, which will tell the TypeScript compiler how to compile our TypeScript. So let me just make that real quick. And we will add a couple of options in here. So the first one is compiler options. And we will have the target set to ES6. We will have the module as ES6. We will have strict set to true. This just makes it so that it will not allow any errors to go into production, sort of, and we'll set the module resolution to node. We'll set ES module interrupt to true. We will set skip lib check to true. We will set remove comments. You don't need to do this step, but I usually like to remove the comments from the output, and then we will set resolve JSON module. I'll pause for a second here in case you need to copy anything down. But other than that, we have two more steps. We have include, and this is just a directory path to include, and we will include source star.ts. This just tells TypeScript that anything inside the source directory with any like subdirectory with the file name ending in ts we will include, and then we'll say exclude I can't type today. We'll set exclude to node modules. Alright, so just a quick overview. These are just some configuration options, like target module, like how TypeScript will compile the code. These are some other things like strict, saying that TypeScript should not allow any errors in the code, and remove comments, skip web check, ES module interop. These are just some general stuff. Alright, so now I'm gonna make a .git ignore. Now this is pretty useful if you don't want to commit stuff to a Git repository, and it's optional if you're never gonna put this on a Git repository, but it's a nice thing to have. So I'll have node modules git node, and I'll also have public bundle.js, and this is where our code is going to be outputted to. It's going to be outputted to a bundle called bundle.js in the public directory. So we don't want that in a Git repository if we ever need to. And finally, we need a webpack.config.js. And this will just include some basic stuff about Webpack. And this is kind of long, so I'm going to explain it as we go. First off, we're going to import join and resolve from the path library. And then we'll have module.export equal to this object when we have the entry as source index.ts. We'll have module with the rules. Hold on. Wait, rules is a list, not an object. We'll have the test as this regular expression .tsx question mark $$ \. We'll use ts-loader, which I actually forgot to install in a second. We'll do that in a second. And then exclude. Again, we do not want to include node modules when compiling. Alright, now we need resolve, and then we're going to resolve extensions with the endings of .ts and .js. Oh, I spelled resolve wrong. You will output into the file name bundle.js, and we will use the path resolve name public. Alright, final thing, dev server. This is going to tell our development server how to run. So we will have static directory join name public. So this is going to tell our server to run on the public directory, and we're going to say it's going to go to port 3000. And I'm just going to format this a little better. Something is wrong here. Ah, I forgot a colon. That's all. Alright. Now, this is everything here. I'll wait for a second if you need to copy anything down. So basically we import some stuff from paths to help us with resolving paths. Our entry is going to be in the source directory index.ts. Our rules, we're going to take anything with tsx, use tsloader, and then exclude node modules. We're going to include extensions of ts and js. I'll put it into bundle.js in the public directory, and when we serve the dev server, we're going to use the public directory to serve it. Now, as I was saying, we need to add the library ts-loader. Just one extra step, and I'll be yep, it's done. That was pretty fast. So, our setup is basically done. Now, that took a pretty long time, but we got it. So now, what you want to do is you want to make a directory called public. And you can do that just with mkdir if you're on Linux. If you're on Windows, I'm not sure. So we will touch public index.html, and this just creates a file inside of the public directory called index.html. Now if I open up a file explorer, you can see what that looks like. So if I go to home, dev, no, not this one, platform.yt. You can see I basically just created a public folder with the file index.html. So you can just do that if you're in like a graphical file manager. You can just create a new folder and then create a new file called index.html. I'm just using command line because it's slightly faster. So now if we go into our text editor, we can open up index.html. And we can start writing the HTML for this project. So we're going to have doc-type HTML. We're going to say HTML. And we're going to have a head. And inside that head, we only need one thing, which is a script. And this script will point to our bundle.js file. And then one important thing to add is this defer part. Defer just means that load the script only after everything else is loaded. And this will be useful because we will have a canvas object, and if that canvas doesn't exist yet, our script will crash. So we will end that script. Oh, that's not good. There we go. Alright. And then we will close our head. And then in our body of the HTML, we will have, as I said before, we will have just one thing, which is a canvas. And you can just do that, and close the body. And then finally close the head. I mean the HTML. So this is literally all the HTML we will ever need in this project. Actually, forget what I said. We need one more thing. We need a style tag. Because, actually I'll show you in a second what it does. So if we open up just a index.html page in Firefox, for instance, you can see we have this blank page, which is what you would expect, because we have not added anything except for a canvas, and the canvas isn't drawing anything. But if we inspect this page, we can see the body is actually, it's not that good, because we have this margin across the top, and we don't want that, because we want our canvas to fill the whole screen. So let's close that inspector, and we'll go back here, and we'll add one more tag called this style tag. Hold on. Alright. And then we will say the type equals CSS. And then, wait, not CSS, text/CSS. And we will say body, and we'll take the margin down to 0. And in case there's any overflow, we do not want it. So we'll say overflow-y, and we'll call it hidden. So this means that if the canvas happens to draw below what the page is seeing, which we will see in a second, we do not want to have like a skull ball on the side. We just want like just hide everything that is overflowing. And then now we can close the style tag, and we should be good. Alright, so now if we try refreshing the page, and we inspect element, you can see our body does not have that gross margin anymore, which is nice. Alright, so now the HTML should be done, and we can move on to the actual coding part, which is the fun part. So let's make a directory called source, or just a folder if you're using a graphical file manager, and then we'll touch source index.ts. So let's make a new file called index.ts in source, and if we go into index.ts, we can start coding. And we're just going to make something simple right now. Let's just color the canvas black. So let's take a look here. We're going to get the canvas. So let canvas equals document.query selector, and we're going to select canvas as an HTML canvas element. Now, don't forget the as HTML canvas element, especially if you're using TypeScript, because if you don't include this, TypeScript will start yelling at you saying that canvas is just a generic HTML element. You want TypeScript to know that it's an HTML canvas element. And then we're going to get the context. Let ctx equals canvas.getContext 2D. And this is just going to get the 2D context of the canvas. Oh, and this, if you take a look at here, it sometimes is null. And we do not want that, because we know that ctx always exists. So we will add an exclamation mark, which tells TypeScript that it always exists. So we do not need the null in there. Now, let's make a constant update loop, which is going to be our main game loop for this project. So let's make this game loop. And it's kind of weird how you do this in JavaScript, but this is the basic gist of it. We'll make a function called loop, and then we will just have it there. And in order to make this loop run infinitely, what we need to do is we need to request the next animation frame of the loop. So we'll say request animation frame, and we'll pass in the loop. So what this is going to do is every single time loop is called, it's going to call itself again. And request animation frame just means that the next time the script updates, we need to call this function. So in a way, it's like, oh, we're going to run this function, but be sure that after this function is done, we want to run this function again. So it's sort of like a while loop in a way, in that it's always calling itself. And then we need to request animation frame in the beginning here, because we want loop to run on the first go. So now, once this kicks off the loop, it'll call itself indefinitely, and we will have an update. Now, how do we color the canvas? Well, after we request the next animation frame, we will say ctx.fillStyle, and we will pass it a color. And in this case, I'll just use black, which is #000000. I think you can also just pass in the string black, which might be easier. And we're going to say ctx.fill rect from 0, 0 all the way to canvas.width and canvas.height. And if we refresh the page now, that's weird. Oh yeah, we forgot to save it. So, we finally have this script this script done. And now we can actually use Webpack to serve this web page. So let's run yarn dev in a terminal, and it should start serving this at localhost 3000. So let's navigate to localhost 3000, which I have bookmarked. So if you just go to a web page, if you just go to your web browser and then go to HTTP localhost 3000, type that into your web browser and you should go to this page where you see this black canvas, which is kind of cool. So every single update, every single split second that the script is running, it's actually continuously refilling this canvas with the black color. But there's a small problem here. This canvas is not the size of the screen. And I don't know about you, I do not want to be playing a platformer that is that small. So let's make this canvas the full screen size. And how do we do that? Well, we can do that with window.add event listener, which is kind of cool. So if you just want to get this done, what you can do is at the top of your script, you can say canvas.width equals window.innerWidth, and we can do that with canvas.height as well. And if we take a look at the web page now, you can see, oh wow, it's coloring the entire screen. So now the canvas is the same as the screen size. But there's a small problem here. Let's say I squish this window down a little bit, and then I refresh the page. Now if I make the window larger, you can see that the canvas does not resize when the window size is changed. But that's just a small fix. What we can do is we can say document.add event listener with the event as resize and the listener as a function. And that function is gonna say the same exact thing. So what this is saying is we're gonna add an event listener on the resize event. So anytime the window is resized, we are going to change the canvas width and the height to the current window width and height. So we should eliminate the problem where the canvas is not filling the whole screen if we resize the window. Now let's try refreshing the page, and then now you can see that's weird. Alright, I found the problem. It is not document.add event listener, it is window.add event listener. Small problem. Let's see if that works now. And yeah. So as you can see, I'm resizing the window right now, and it is constantly updating, so the canvas will always be the same size as the window. So that problem is eliminated now. And now we can see it's working really well. We have a canvas that we can draw stuff on. And to test that out, for instance, let's say we wanted to draw a rectangle on the top left corner of the screen. We can say ctx.fill style equals white to make it stand out, and we can say ctx.fillRect at 0, 0, and we can set the width to, 20 pixels, and the height to 20 pixels. So now you can see there's a 20 by 20 square being drawn on the top left corner of the screen. Nice. Now this is the basics of how we draw on the canvas. We use fillRect to fill a rectangle, and then we just always put it inside this loop. Now, this is going to be pretty long, this script. So, in order to organize the code, we might want to put this in a separate file. So for instance, let's make a new file. And let's go to cd dev, cd this, and then we're going to say touch source game.ts. And this file is going to contain all the game logic. So let's open that real quick. And then I'm just going to split this so we can see both of them at the same time. Alright, so we're basically going to make the game a class, and this is just going to help in organizing our code a little bit. So we're going to say export default class game, and we can basically just copy and paste this code up here. with some small tweaks. Let's just bring this down here and basically just copy all of the code into this new class, and then we need to make some adjustments. Let's make this a private canvas and a private CTX because we don't really need anything else to be seeing all this stuff. And we also need to change this to this dot canvas because canvas does not exist, but this dot canvas does. Now, in our constructor, this constructor method is called whenever a new instance of this class is instantiated. Basically, this constructor is called on the first instance, or like the first one of this class, sort of. So let's move this changing the canvas width and height into here so that it always runs whenever a new game is created. And this is just gonna be extra organization. Alright, and then we're gonna add the event listener in here as well. And yeah, so our loop thing, I sort of want this loop to be inside of the index file, so like the index is calling the loop. So let's rename this. Let's make a public method called tick, and then we're just gonna put all this code inside. Let's move all this code inside here. And we gotta make sure to add this dot in front of everything. One second here. Alright. So, now as you can see, the code is slightly more organized as it is put inside its own class in its own file. So if we go back to index.ts, we will need to call this tick method every single update. And how do we do that? Well, first off, we need to import the game. So let's import the game from the game file, and we will say const game equals new game, and we will say const loop equals this, and then request animation frame on loop, and we'll say game.tick. So this is basically what we had before, except we were just calling the game tick instead of putting everything inside the loop. So this will just help in organizing our code a little bit. And if we go back to our web browser, we can see it's doing the exact same thing, but now the code is just a bit cleaner. Alright, now here comes the fun part, coding in the player. So the player is kind of interesting, because if we want to organize this a bit, we can say that the player and the walls of the platformer can all be considered as entities. And with object-oriented programming, we can extend an entity class to reuse code that we've already written. So let's touch source entity.ts, and this will be a pretty cool class. So let's make a class entity. Export default class entity, and we'll say protected position, and I'll give this a type later. Protected size, protected sprite. No, actually, no, we don't need a sprite on this tutorial. And yeah, so position and size. What type would that be? We don't really have a type for this in TypeScript, so I'm going to make our own type. And we'll make a vector type. A vector is basically a tuple of two integers, and it's going to have a y and an x. So let's do touch source lib.ts, and then let's go back to NeoVim, and let's take a look at lib.ts. We're going to export an interface called vector, and we will give it two properties, an x, which is a number, and y, which is a number. And then now we can import this entity and use that as a type for position and size. So position is going to have an x and a y, and our size is going to have an x and a y, which is going to be kind of nice. So in our constructor, public constructor, we're going to take the position, which is a vector, and we're also going to take a size, which is a vector. And we will say this dot position equals position, and this dot size equals size. Nice. And for good measure, let's have a protected color, which is going to be a string. So let's say color, which is a string, and this is just going to be the color of the thing we draw. This dot color equals color. Now let's make some more helper methods. So for instance, let's make a method called public draw, and draw is going to take a CTX, which is a canvas rendering context 2D. This is just going to be a context that we just declared in our game file, and we're also going to take a camera position, which I'll talk about later. So let's take ctx.draw.fillStyle equals color. Now this is going to set our fill style to the current color of this entity. And we're going to say ctx.fillRect, and we're going to fill it at this.pos.x minus this.size.x minus over 2. I'll explain this in a second. This.pos.y minus this.size.y over 2. We're going to make the width this.size.x, and we're going to make the height this.size.y. Alright, so why am I subtracting this.size.x over 2 from this.position.x? Well, it has something to do with how HTML draws images on the canvas. So positions aren't actually calculated from the center of this object. 0, 0 is actually at the top left of the screen, and for instance 100, 100 is somewhere around here. So just to make it easier on ourselves, I want it so that 0, 0 is on the middle of the screen, and this is negative, this is positive, this is negative, this is positive. So rather than starting drawing from the top left corner, we're going to draw it from the center. And that's why we're subtracting half of the width and half of the height. As you can tell, if we're taking the top left corner and we subtract half the width, well, that's the same as moving the square half to the left, which will center it on the middle. And we're going to do that for the same as the y as well. So if we subtract half of the width and half of the height, it's going to move this anchor point to the middle of the object, which is exactly what we want when we're drawing. And we're actually going to subtract cam.x and cam.y. So this isn't just going to be an ordinary platform. No. We're going to add some scrolling to it, which means that we're going to have this camera that's going to be following the player, so the player can go infinitely in any direction, which will be kind of neat. Now, let's make some more helper methods. We're going to say public get position, Now this is just going to get the position since we made it protected. Let's make a public get bounds, and this is just going to return the boundaries of this entity. And it's sort of like what we did before, but a little bit more complicated. So the left boundary is going to be this.pos.x minus this.size.x over 2, as you can see up here. And then, well, let's copy this 4 times. We're going to make a right boundary, a top boundary, and a bottom boundary. And the right boundary is going to be this.pos.x plus x over 2, which is going to get the right boundary of this entity. The top is going to be the y minus this.size.y over 2, and the bottom is going to be this.pos.y plus, well, this.pos.y plus this.size.y over 2. Now, you might be wondering, why are we subtracting when we're taking the top, and why are we adding when we go to the bottom? Well, it's also a thing with how canvases are rendered. As we go more up, the y actually gets more negative, and as we go more down, the y gets more positive, because 0, 0 is up here, so this is actually going to be like 100y. This isn't negative 100y, this is 100y, because 0, 0 is up here. So in order to go up to get the top boundary, we'll need to subtract rather than add. So just a little bit of a thing to pay attention to. And then finally, we're going to add some collision detection in this class. So we're going to say check collision, and we're going to take a other, which is an entity. And we're going to say return, and this is going to be a pretty big if statement, sort of. We're going to return this dot bounds dot left is less than other dot bounds dot right, and let's copy this a bit. This dot bounds dot right is greater than other dot bounds dot left, and this dot bounds dot top is less than other dot bounds dot bottom, and vice versa. This dot bounds dot bottom is less than other dot bounds dot top. Now you might be wondering, what the heck is this? Good question. This is how we check collision detections. Alright, I have found a drawing tool. So, let's say this is our first rectangle right here, and this is the entity itself. Alright, I'll just call this E. Now, let's say we have another rectangle right here, and as we can see, these two rectangles are overlapping in this section right here. And we're going to call this other, O. Alright? So, let's take a look back here. If this dot bounds dot left is less than the other dot bounds dot right, alright? So, this is the left boundary right here. This plane is the entire left boundary, and this plane is the right boundary of the other thing. Now, is this x value less than this x value? Is the x value of E's left boundary less than the x value of O's right boundary? Well, yeah, it is, as you can see right here. So that means that these two x's are overlapping. But not yet. What if they aren't? Because we can achieve the same effect if we had E right here and O right here. Let's say this is E, and this is O. Sorry for my bad handwriting, I'm using a mouse. Now this x value is clearly greater than this x value. But are these rectangles overlapping? No. But that would trigger the collision detection if this is all we had. If this dot bounds dot left is less than the other dot bounds dot right. But why are these overlapping? Well, that's because this has gone way too past. This entity has gone way too past the other, to the point that this side is no longer in contact with this side. So we need to check for something else. We need to check that this dot balance dot right is greater than other dot balance dot left. So as you can see here, this dot balance dot right is less than other dot balance dot left, which means that this x is not overlapping because it has gone way too past the other to actually trigger a collision. But in this case, yep, this right is greater than this left, which means that this is still not too far past, which means that the x is currently colliding. But there's something else. We have so far checked the x collisions, but what if we had E right here, and then we had O right here? Now, are these two objects colliding? You'd say yes, but according to our program so far, it would be no. Even though the x is currently overlapping on this small section right here. We haven't checked the y collision either. Now, if the y isn't colliding, then these two objects aren't colliding, because, well, there's this gap right here. So, that's why we're doing the same exact process, but with the top and bottom of the respective entities. So now, these should be colliding. This is all we need to check collisions between two objects. Oh, and sorry for the confusion, this is a greater than sign, because we want to check if the bottom is greater than the top, as like that, basically. Alright, so our entity class is now done completely, and that is nice. So let's take a look at creating the player now. How long is this video so far? Oh wow, 44 minutes. So yeah, let's touch source player.ts, and this is going to be the file for our player object. Let's export default class player, but not so fast. We want to extend the entity class because player is an entity, so we're going to say extends entity, and auto imports for us. And we're going to say we're going to have some extra stuff in this player class. We're going to have a private velocity, which is going to be a vector, and it's going to have an x of 0 and a y of 0. Now this is going to be the velocity of the player. It's going to control how the player moves every single update. We're going to say private grounded. This is going to tell us if the player is currently on the ground, which is going to help us see if the player should jump. Actually, let's skip that for now. I'll show you what happens if we don't add grounded. And what else? That should be good. So let's say public constructor, and we're gonna say super. Super just calls the constructor of the parent class, I guess. No, super class. Yeah, it's gonna call the constructor of the super class. So it's gonna call the constructor of the entity with an x of 0, y of 0. So we're gonna start at x. We're gonna start at the middle of the screen, x 0, y 0, and we're gonna set this x to, let's say, 20, and we're gonna say y is 20. So this is gonna be the size of our player, 20 by 20 pixels, and we're gonna make the color, let's say the player is gonna be white, just to make it stand out. You can choose any other color you want. So let's say, yeah, okay. So public tick. Now tick is going to be called every single update, and let's just do something simple for now. So it's going to say this.pos.x plus equals this.vel.x, and this.pos.y minus equals this.vel.y. And as before, we're using minus equals because as we go more up, the y value gets negative. So instead of adding, we're going to be subtracting y, and that's going to just help us later on. And yeah. Now, something you might want to consider is we were just declaring that the width and height are 20 and 20 so far, but we can actually just make these into constants. And how I like to do that is in the lib file, I like to export a const size equals 20. So now, whenever we want to use a constant, oops, my bad. Whenever we want to use a constant, we can say x size, y size. So instead of having to go back and edit all of these variables, we can just go back to the lib file and we can change the size manually. Now, how do we actually run the player? Well, in our game file, we can call it in our tick method. So let's go to game. In our tick method, we are currently resetting the canvas by filling it completely with black, and then we can say this. Wait, we haven't had a player yet. Forget what I said. We're gonna make a new player first. We're gonna say private player equals new player. Alright, and then now we can say player.tick. Yeah. So we're gonna tick the player, and then next we're gonna draw the player. And you'll see we need a context, and we also need a cam. But we don't have a cam yet, and I'm getting to that. The camera is just gonna be a vector which stores the position of our camera. So let's go to the very top here, and let's make a camera. So private cam is going to be a vector, and it's going to equal x negative window dot inner width over 2 y negative window dot inner height over 2. And the negative window dot inner stuff, that's just going to get the middle of the window. So the camera is going to start in the middle of the window, which centers our player not at the top left, but at the middle of the window, if you sort of understand what that means. We're going to import a vector, and we're going to say this.cam. And if we go back here, you can see, oh wow, we have a player being drawn here. Now hold up a second. We had the player moving the x and y. So why isn't the player moving right now? Well, if we go back to player, you can see the velocity x and y are 0 right now. But let's say we change the x to 1, and now the player is slowly moving. Look at that. We have successfully created a moving square on the screen. That's the basics of it. Let's move that back to 0. And then now we can start coding the actual movement of the player, which is going to be super fun. So let's go back to game. And I don't think we need this anymore, so we're just gonna quit that. Now, in our tick method, actually no, not in our tick method, in our constructor, we're gonna add some more event listeners. So we're gonna say document.add event listener. We're gonna listen for the key down event, and we're gonna say this.handle key. Hold on. We're gonna say event this.handle key event, and we're gonna pass in true, and I'll explain what this is in a second here. This.handle key event false. So let's make the handle key method private handle key. We're gonna say event, which is gonna be a keyboard event. That's weird. Oh, the B is under lowercase. Keyboard event, and we'll just say down, which is going to be a boolean. So, let's make a switch statement on event dot key. Oh gosh. Switch event dot key. And we're gonna say default, we're just gonna return. So if we have nothing written, we're just gonna return. If however we get a arrow left, basically the left arrow on our keyboard, or we get a key. So both of these correspond to the left, right? Arrow left is just the left arrow on the keyboard. A is basically the left arrow but on WSD. So if any of these keys are pressed, we're gonna say we're gonna set this dot keys dot left equals down and break. Now we don't have keys yet. This is gonna get a little bit confusing. We're gonna have private keys equals, I'm gonna say left false, right false, and jump false. So basically we have this object of keys, and keys has left, right, and jump. So sorry, the recording stopped for a second, dude. So wait, hold on, let me just change this real quick. The handle key. We have private keys, left, right, jump, and this is just gonna store the current values of the keys. So if the right key is being pressed, we will have right set to true. If the left key is being pressed, we'll set left to true. And if the jump is being pressed, we'll set jump to true. So as you can see here, on the key down event, so the second the key is being pressed, we're gonna call this dot handle key event is true, and that's gonna call this. So let's say the A key was pressed, right? We're gonna say handle key A true, right? And we're gonna have the switch statement, and that switch is gonna catch this A. So the A is being pressed, and we're gonna set this dot keys dot left equals true, because down is true right now, and we're gonna break. Now let's do this for the next couple of things. We're gonna say arrow right, case D, and that, and we're gonna say arrow up. We're gonna say case W, and we can also add case. We'll use a space being pressed, and we're gonna say this dot keys dot jump equals down. So what this is saying is, if we're it's just gonna catch all the arrows. So it's gonna say right, left, and up, right? So let me change this to right. If the right arrow is being pressed, we're gonna say this dot keys dot right is true. If the left arrow is being pressed, we're gonna set left to true. And the most important part is this key up event, which is saying that if we release the key, we're gonna set that key to false, as you can see right here. So if we release the key, the second the key is released, we're gonna set the key to false, which stops the player from moving in the direction. Because you do not want your player to just keep on moving to the right, no matter how far it goes. Alright, so now that we have these keys, we can tell the player to move. And we're going to make that in a second, but let's just say this dot player dot move, this dot keys dot left, this dot keys dot right. Phew, that's the key handling. Now we don't have this move method implemented yet, so let's implement that real quick. Let's go to the player file, and let's take a look at how you move the player. So let's make a new function, or a new method called move, and we're going to take in left, which is a boolean, basically if the left key is being pressed, and right, which is a boolean. So this is going to tell us if the right and left keys are being pressed, and we can do stuff with that. So let's say if left, this dot val dot x plus equals speed, and actually, yeah, we can just put that in lib. So say export const speed, and so this is just going to be the speed of the player. And let's set that to, hold on. Let's set that to 0.5. I have like a I have like a script basically that's telling me all these constants just to make sure I get them like a pretty good value. Let's set that to speed, and if the right key is being pressed, we're gonna minus equals speed. Now this is pretty cool, because what this is doing is if the left key is being pressed, we're gonna add speed onto the velocity, and if the if the left key is being pressed, we're gonna add speed. If the right key is being pressed, we want to minus speed. And I just realized I did that wrong. We need to minus and add, because right goes plus x, left goes minus x. So every single frame when this is being called, we're gonna check if the left key is being pressed, and if so, we're gonna subtract speed from the velocity. And if the right key is being pressed, we're gonna add speed to the velocity. And the nice thing about this is if both keys are being pressed, these two actually cancel out. The plus and minus cancel out, which means that we will have no net add to the velocity, which is kind of nice. So now, this is the fun part. If we go back to here, and I'm pressing down the right arrow key, you can see that the player is accelerating. I'm controlling the player right now with just my arrow keys, and this is pretty cool. But oh my gosh, this is a fast boy. The player is going quite fast. Now, why is this? Well, we do not have friction yet. So I'm going to add some friction right now. Let's make a constant in our entity class called friction. And, our lib file called friction. Let's say export const friction, and I'm just going to set it to 0.9. Which means that every single time, the x value is going to get multiplied by 0.9. So let's say this vel.x times equals friction. And now if we take a look here, the player starts slowing down after we move, as you can see here. So this just makes it a bit nicer. We don't want the player to be flying across the screen. We want the player to slow down if you release the arrow key. And as you can see here, it's kind of smooth. It has this gliding effect where it starts slowing down. And it's actually a lot better on my screen than the recording probably, because the recording is kind of jittery. So if you do this on your own machine, you should have a pretty smooth scrolling effect. Alright, now what about the Y movement? Now for the Y movement, we probably want some more constants. Let's say export const gravity equals 0.5, and this is just going to be gravity, like the force pulling the player down. And we're also going to have export const jump, and this is just how far the player is going to jump when you press the up arrow key. And we're just going to set that to 10. Oh, equals 10. So let's say this vel.y plus equals gravity. So every single update, the player is going to fall at gravity. Oh, not plus equals. Minus equals. My bad. Yep, you can see the player is now falling due to gravity. And what we can do is we can make a jump method. So in our player class, let's make a method called jump. And we're going to say this.vel.y plus equals jump. Nice. So now, as you can see, I forgot to add the method into the class. Into the game. Oh wait, let's try that again. So we're going to say if this.keys.jump, we're going to say this.player.jump. So only if the jump key is being pressed, we're going to allow the player to jump. And that should be pretty straightforward. Let's run that in the browser. As you can see, oh, that is not good. The player is jumping a bit too fast right now. Now, why is that? Well, we don't know if the player is on the ground right now, so we were just constantly adding 10. If the player is in the air, it's like if you jump into the sky, and then you can just keep on jumping on air. That's just like pushing yourself off of the air, which is kind of bad. So, let's fix that. First off, let's make an entity. we can set that entity to be our ground. So let's say private ground equals new entity, and we're gonna set that entity to have, let me see, we need a position, a size, and a color. Let's set the position to, I don't know, x0, y, y negative 100 maybe. I'm just guessing at this point. Actually, no, wait, y 100 maybe. And then the size, let's set the size to x, let's set that to 100, y, maybe 20, and let's give it a color, white. Why not? And we're gonna say down here, what is wrong with this? I have this. Alright. So down here, let's just draw this ground here. This.cpx, this.camp. So we have this ground now, and let's say we only want the player to be able to jump if he's touching the ground. So in our player right now, let's add some more logic. Alright, so in our player right now, let's go to the tick method, and we're gonna add some stuff. Let me think about this. Let's just take in a ground, which is an entity. And basically, what we're gonna do is we're gonna say, after we change the y position, we're gonna say this dot grounded equals false. So let's make this grounded thing up here. So private grounded equals false. So ground is just gonna tell us if the player is touching the ground, and if we're touching the ground, we should be able to jump. So for no, not a for loop. If this dot check collision, so if we're colliding with the ground, we should be able to jump, right? So we're gonna say this dot pause dot y first, minus equals this dot vel dot y is greater than 0. This dot bounds dot top minus ground dot bounds dot bottom, this dot bounds dot bottom minus tile dot bounds dot top. Now what this is checking is if this y value is greater than the tile, we want to move the player up, and otherwise we want to move the player down. Basically, if we're colliding with the ceiling of this, we want to move the player up. If we're colliding with the bottom of it, we want to move it down. So we don't want the player to be like teleporting from the ground up, and that's what this is for. So let's say this dot vel dot y equals 0. We're just gonna set the velocity to 0, and we'll say this dot grounded equals this dot pause dot y is less than ground dot get position dot y. Alright. So now the final part is I'm gonna say if this dot grounded, we're gonna only allow the player to jump if we're being grounded. And then now if we go back to game, we can say this dot player dot tick with this dot ground. So now as you can see, we can jump, but only if we're touching the ground. And that's super nice. So let me just go over this a little bit to explain how this works. So we're going to check collision with the ground after we've moved the y. So if the y is currently like going past the ground, this will activate the if loop. And it'll say this dot pause dot y minus equals that. And we're going to say this dot vel dot y is greater than 0. And this happens. So basically what's happening is it's checking if the player is touching the ceiling or the bottom of this. And if it's touching the ceiling, we want the player to go up. If it's touching the bottom, we want the player to go down, because we don't want the player teleporting through the platform. And then we're going to say this.val.y equals 0, so the player just stops its y velocity. And then we're going to set this.ground to true. So it's only going to be grounded if the player is above the platform. You're technically not touching the ground if you're hitting the ceiling of the platform, so we don't want the grounder to activate like that. And yeah, that's how you can add a simple platform to the game. Now, let's try adding... what do you want to add? Oh yeah, we want to add X collisions. So right now we have the Y collisions. The player is colliding in the Y axis. But let's say we go to game and we make this entity. Let's make this like a bit bigger, maybe 500. So the platform is a bit longer. And let's maybe add some basic walls over here. So let's make another thing. Let me think about this. How do you want to go about this? Yeah, so let's make a tiles array in game. So instead of just having one thing that we're colliding with, we have many things that we can collide with. So let's say private tiles, which is just going to be an entity array. And basically, we're just going to add stuff to the tiles array. So let's add this new entity into the tiles. So let's do that, and let's make another tile. And this tile is going to be at x, maybe x200, y 0, I don't know, x 20, y 100 maybe, and then we're going to set it to white. And now we can pass in this dot tiles into the player. And yeah. Sorry. In our player object, we are going to, instead of just checking collision with the ground, we're actually going to check collision with a bunch of ground objects. So basically an entity array. And we're just going to say, for tile of tiles, we're going to run the if statement. So if this dot check collision with tile, we're going to say tile.bounce, tile.this, tile.get position. This is just basically going to run through every single tile and then check collisions with it. Oh yeah, we need to say const tiles to tiles. So now, instead of just checking collision with one tile, we can check collision with many tiles. And then right here, we can say for const tile of this dot tiles, tile dot draw. So now, instead of just having one tile, we can have many tiles, right? As you can see in the player. And now look, we have this. Let me just make that a little bit bigger, or just lower a little bit. So let's change that y to like 50 maybe. And yeah, so now as you can see, oh, what is this? We're teleporting to the top of a platform. That's not something we want. So how do we fix that? Well, the thing that's going wrong right now is that the player isn't colliding with the x. So the player is just teleporting to the top of the platform. So how do we check collisions with the x? Well, in the same way that we check collisions with the y, we ought to do the same thing with the x. So after we move the x, let's do this. For const tile of tiles. If this dot check collision with tile, we want to do some stuff. Now, what do you want to do? Well, we basically want to do this exact same thing, where we check if we're on the left or right of the tile. So if this dot vel dot x, if this dot pause, wait, hold on, I copied the wrong stuff. We brought this thing. Sorry. If this dot pause dot x is minus equals this dot vel dot x is greater than 0. So if the player is currently moving to the right, we want to change the x so that it's going backwards. So we want to go from the right to the left. So if the player is moving to the right, if the player is going to the right, then and it collides into a wall, we want to move the player back to the left. We don't want the player to keep going right, or else the player is just gonna go, just travel through the wall. We want the player to go back, so the player hits the wall and stops. And then, if the player is going from the left to the right, and it's like the player is going from the right to the left, so if the player is going backwards, we want the player to hit the wall and go to the right to stop. And that's, and we're gonna like this, and we can say this dot vel dot x equals 0. So if we run this now, we can see the player is now pause dot x minus equals we're checking the y velocity here, not the x. Alright. So as you can see, the player is currently colliding with both sides of the wall. I'm pushing the arrow keys into the wall right now, and the player is just stopping. Now that's what we want, and this is basically everything for the platformer. Now I'm gonna add one extra step in here, which is how we can create maps easily. But this is basically it. If you want to just stop right here and just add tiles manually from the game thing, that's what you can do. Just keep on adding platforms. Your player will collide into them, and it should work great. But how do we use like a file to design a map for this? Now, this is an interesting part because it has a little bit of math in it, has a little bit of everything. So let's make a new file called touch source, call it map.json. And let's open up map.json, and let's just make a map. So for instance, if I go into the map.json right here, and then make a new list, I can basically make a map with this list. So what I can say is zeros are going to be air, and ones are going to be walls. Oh wait, I just forgot something. Hold on. My bad. I forgot to implement the camera movement. I was saying that this is going to be a scrolling game, so we should probably add some scrolling into this. So if we go back to game, we can see we have all of this player stuff right here, and we can probably change the camera. To follow the player. So let's say this.cam.x equals mass.round this.cam.x minus this.cam.x plus this.canvas.width over 2 minus this.player.getPosition.x. And then we're going to multiply all of that by follow.x. And we're going to make this follow thing inside of here, inside of the lib. So we're going to say x_const underscore follow. We're going to set that to a vector equals x. And let me just see what I put here for the follow. The x is going to be 0.05 and the y is going to be 0.1. So this is basically how fast the camera is going to follow the player. So the closer this the closer this value is to 1, the more the camera is just gonna like lock onto the player. And so 0.05 is gonna make the camera a bit smoother. So if we go back to this, and then we change this to follow.x, that's done for the camera following x. And we can do the same thing for the y. This.cam.y equals this.cam.y minus this.cam.y plus this.canvas.height over 2 minus this.player.getPosition. Oh my gosh. This.player.getPosition dot y times this times follow.y. Yeah. So now you can see the player, the camera is sort of like smoothly following the player, and it has this sort of motion, and it should be like a little bit better on your screen. Yeah, it's a little bit glitchy right now because I'm running OBS in the background, but it should look pretty nice on your screen. So as you can see, the camera is now following the player. The player is constantly in the middle of the screen, which is kind of nice. Now, let me explain the math behind this. What we are doing is we are taking the camera x, we are subtracting the current camera x plus this.canvas.width over 2. This just makes the camera centered on the screen. If the camera wasn't centered, the player would be way up here. The player would be like, it would be centered, but it would be up here. So adding that just brings everything to the center of the screen right here. And then we're subtracting this.player.getPosition.x. So basically, let's say the camera is right here, and the player is right here. So if camera minus this, that's going to be a positive value, right? So now, if that's a positive value, we want the camera to move backwards. So we're going to subtract that from the current camera position. But we're multiplying this entire thing by follow.x, which means that this isn't going to just snap back. This isn't just going to like immediately go from here to here. It isn't going to just like teleport the camera. Instead, what it's going to do is it's going to take only a fraction of that. It's only going to take 0.05 of that. And basically, it's going to turn that, it's going to slowly and gradually go back. So it has this smooth like transition rather than just immediately snapping onto the player, which I kind of like. So that's the camera, and that's how we added all the stuff into Entity about subtracting cam.x and cam.y. It just allows us to, you know, I can't find the web page. There we go. It just allows us to easily allow the camera to snap onto the player. Now, loading the map. So, let's make a map first. If I go into map, map.json, I can start making the map. And we can declare stuff like, let's say, zeros are air and ones are walls. So let's just make a simple map right now. I don't know. Let's say 1, 0, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Alright, and then we're gonna have a 1. So it's just gonna be 10 by 10. And I'm just gonna copy this, paste it a bunch of times. I don't know. How many is this? That's 16, so maybe delete a couple. How much is that? 10, perfect. Alright, so this is just gonna be a simple map. We're gonna change all of these to 1s. So basically, you can sort of see how this is like a grid. So each one of these 1s is a wall, so I'm just creating like a boundary right now, and each one of these 0s is air. So maybe we add a couple more platforms, maybe up here, and then up over here. We add like this, I don't know. So that's gonna be our map. Now how do we render this map into our actual world? Well, that's gonna be the interesting part. If I go into the game object, what we can do is we can create a new method called load map. So let's say public load map. And we're going to say map is going to be a number array. So it's going to be a 2D array of numbers, as we just saw in the JSON file. It's going to be a 2D array of numbers. I'm going to say for let I equals 0, I is less than map.length, I plus plus, oh gosh, and for let j equals 0, j is less than map I dot length, j plus plus, and this is just basically looping through the entire map. It's going through all of the rows and all of the columns. And we're going to say if map I j equals 1. So if that segment of the map is a 1, we want to add a new tile onto it. So we're going to say this dot tiles dot push, and we're going to push a new entity of location. And this is kind of weird with the math. We're going to say j x is going to be j minus map I dot length minus 1. Let's go back here. Over 2, and then we need to surround this all in parentheses times size, and then our y is going to be I minus map dot length minus 1 divided by 2 times size. Now, what the heck is this? Oh. Expected 3 arguments, forgot 1. Oh yeah, we need the size too. So, our size is going to be x size, y size, and then the color, we're just going to make it white. So, now, what is this doing? Well, basically, the eyes are the rows of the map, right? So, we're going to be looping through all of the rows of the map. So let's say I is 0, 1, 2, 3, 4, 5, so on. And then we're going to be looping through all the columns of the map. So 1, 2, 3, 4, 5. So J is the columns and I is the rows. And you can see how I can be sort of the Y value and J can be sort of the X value. So if we go back here, you can see that X is the J value and Y is the J value. But what is all of this? Well, the map dot length, that's just how big the map is. So it's 10 by 10 right now. So all of these are just going to be 10. Now we're subtracting 1 because there's sort of a center to the map. If we just use 10, the map is just going to be slightly offset when we make the calculations. So we want to subtract 1 to make the map centered on the player. And then we're going to divide by 2. And we're dividing by 2 because if we didn't, the center of the map is going to be up here. If we divide by 2, the center of the map is going to be right there. So now our map is going to be centered on the screen. And then we're multiplying by size because otherwise we'd have 1 pixel tiles, which isn't that good. So we're multiplying that J and I value by the size, and that's going to give us, instead of like, what is that, -5, -4, -3, -2, or whatever, it's going to give us -100, -90, -100, -80, -60. So our tiles are of size 1. Oh, so now we can go back. Let's delete all of these from our tiles, and we're just going to make the tiles an empty array. And now in index, what we can do is we can say game.loadMap, and we're going to import the map. So we're going to import map from map.json, and we'll say load map. And as you can see here, whoa, we have just managed to load a map from a JSON file. Now that's pretty cool, isn't that? And as you can see here, all we needed to do that was with this 2D array manipulation. We loop through all the values of the array, and we use the I and j values, the rows and columns, to actually calculate what we needed for the map. As you can see right here, we successfully created this map. It's working really well. And as a bonus, I just like to make the player a little bit smaller so the player fits a little bit easier through the holes in the map. So let's divide the size by 2, and now, yep, the player is a bit smaller. It's a little bit easier to navigate through the map. Actually, I don't know about that. We can change it back. The player looks fine as it is. So that's how you can make a simple platformer. I'll make the player blue too, so it's easier to see what we're doing right here. There we go. So yeah, that's basically it. And how you can extend this is you can make this map a little bit bigger. I'm just using a 10 by 10. As you can see on the screen, that's pretty small. You can make this thing 100 by 100, and it'll cover the entire screen, and you can do some scrolling with it and a bunch of cool stuff. You can also make new tiles and add new functionality. As we saw with the player, we extended entity and we added a lot of functionality to a single entity, and that's how we made the player move as it is, even though the player itself is still an entity right now. It's doing all the collision detection, all the drawing, everything the same as an entity, except the player right now has a lot of cool features that allow it to move, which is really neat. And yeah, I think that's about it. That's basically it for this platform tutorial. It was kind of a long video with a bit of stutters in it. I might go back and post and just edit some stuff, add some cool tips and stuff. But other than that, yeah, if you like this video, please give it a thumbs up and a subscribe. This took a while to make, so yeah. I'll also put a link to the code in the description below. I'll probably have a GitHub page for this, where you can just look at the code and even like just clone the repo and test it out for yourself. So yeah, well, see you in the next video.